Okay, so we're gonna look at part 2 of advanced class features. Once again, advanced class features involves just a bunch uh, of individual topics about classes. So we should avoid returning a reference to a private data field because we have set the field private in order to prevent clients from getting at it directly. That's the whole idea of encapsulation in object-oriented programming. So if we return a reference to it, we defeat the purpose because client programmers then can modify the data elements. It's easy enough to create a quote-unquote immutable or unchangeable object by not including any getters, any getter methods. If we don't include any, then we can't get the values unless we return a reference in some other method. Now the second item to talk about is a null pointer reference or a null reference. When an object is null, it doesn't point to anything, even though it has declared a certain class that it's a type of. And so a null reference cannot launch a method. So when you get a null pointer exception, the first thing to check is what objects call that method, what object called that method, and is it set at that point. So one easy way to prevent null pointer exceptions is to wrap an if name not equal null around the reference. Here's an example of a program that depends on full name, which is defined in elsewhere. But let's assume that full name's constructor does not define getLength. If so, getLength name is going to crash the program because getLength is not defined. So let's talk about the this reference. This just points to the object itself, and that can be used in several circumstances. It helps overcome shadowing if in this constructor set feet took an argument of int feet, and then it had an instance field of feet, well, that would be shadowing. It would shadow it, and it would only be valid within the feet would be a different value inside the method. So we use this to point to this object. This dot feet equals feet. So there's a local parameter and an instance variable. We can use this for several other purposes too, but it's basically a good way to point to the object itself. Here's another example of where it can be used. It could be used as a call to a constructor, another constructor. So in this example, we want to provide a constructor that has the symbol, takes in the symbol of the stock value. But for simplicity, we want to pass that symbol on to the other constructor, which sets the value at 0.0. If the call to the other constructor is the first element in the outer constructor, then it calls a constructor. So it has to be the first statement in a constructor in order to call another constructor. So here's an example of the three constructors that we talked about, and down at the very bottom is the keyword this. All right, so here's an entirely new topic called an enum, or an enumerated type. Sometimes we know a set of values and we don't want to go through the trouble of correlating them with numbers, or integers, or whatever. So, for example, the 7 days of the week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. They're not going to change until some Roman Caesar comes along again and changes them. Or if you go to France, I suppose. So you could declare an enum and you could use it like this. Day is a work day, so the day is the enum, work day is the class, and then you assign it. So it's the same situation as any other variable. You declare it, you define it, you declare it, and then you assign it. So now, and only then can you do the third thing, which is to use it. So in this case, day.Wednesday is usable. Workday is usable. So here's the enums again. And workday is an address that points to the fourth workday, Wednesday. So enumerated types have methods. They have a toString that returns the name. In other words, Wednesday would be if you said workday.toString, it would return Wednesday after setting it Wednesday. It has a method called ordinal. Ordinal means the zero-based position of the constant in the enum. For example, the ordinal for day.Thursday is 4. It has an equals method. If the argument, it returns true if the argument is equal to the enum constant. It has a compare to method, and compare to is useful. It returns a negative integer if the constant's ordinal is less than the argument's ordinal, and a positive if they have to be reversed, and equals if they're the same. So here's an interesting enum car type. Now this guy is obviously a big spender because his car types include Porsche, Ferrari, and Jaguar. And there's another enum of car colors, red, black, blue, or silver. And so when this class sports car gets created, it declares several enums, just like always. So Java allows you to test an enum constant with a switch statement like this. You could also, another example is an enum is a basketball position. There are only 3, guard, forward, and center. And you could declare that. So we go on to the next topic, garbage collection. When objects are no longer referenced or no longer needed, they need to be recycled, or the memory needs to be let go. So if you set a reference to null, or you set a reference to point to something other than what the object had originally pointed to, Java will eventually reclaim the memory. So the Java virtual machine has a process that runs in the background that reclaims memory. It's called the garbage collector. So if you had account 1 equals bank account, a certain bank account object, and account 2 is set to account 1, they're both set to the same thing, as in this diagram. If now account 1 is set to null, account 2 is still pointing to the bank account object, so it's not garbage collected. But then if account 2 is also set to null or set to another object, then balance has nothing pointing to it. There's no way that the Java program can get to bank account object anymore. And so it's garbage collected. Now, right before garbage collection happens, there's a method called finalize. If you have something that you want to run just prior to garbage collection, then you put it in a method called finalize. Garbage collection is uncertain when it's going to run, and therefore finalize is unknown when it's going to run. But what's guaranteed is that if you cut off an object from any reference to it, then it'll eventually get garbage collected. Okay, class collaboration. If two classes interact with each other, this is very similar to aggregation, but it's not quite the same. So two classes collaborate with each other. It's called class collaboration. So if we design a stock purchase class that collaborates with stock class and stock trader, it can be called collaboration. There's no direct relationship between stock purchase and price and stock, except via the stock trader. In this example, it creates an aggregation relationship.